Good evening, students. I have come with this video on the topic of concave mirror. This is from NCERT exemplar, problem number 9.8. But as usual, I will not solve this problem directly. I'm going to give you some very interesting points to think about and leave you with some very important concepts which will help you solve further problems. My channel is the only channel in the country which is providing explanation. No other channel, application or web portal you will see will give you any explanation. Solutions are fine. You can see the solution, but what is that you learn? Nothing. In my channel, what you will find is you will learn something. Apart from the solution which you can see from any portal, any application of your choice. I don't mind that, but learning point of view, my sincere request is please subscribe to this channel because of its excellent explanation. Let's come to first understand the concepts which are very important and are associated with a mirror, and then we will solve this problem in the part 2 of the lesson. The first part of the lesson will go deep inside understanding the mirrors, and after that learning you will see yourself that solving this exemplar problem will become very simple for you. Let's go and understand the lesson number 1. Alright, so the first lesson deals with the concept of a mirror. So first understand that if you're seeing this concave mirror, I can draw other mirrors also. If you see a concave mirror, okay, and you see these lines, okay, these lines, these are the lines you're seeing. So I'm talking about construction of the concave mirror. The reflecting surface or the mirror is here. This side is the mirror, okay. This is the back side. This is not the mirror. This is dark. So this is the inner surface or the reflecting surface. Let me call it the reflecting surface. Reflecting surface of the mirror, right? I hope this is clear to you. So these lines which you see are not the reflecting surfaces. For example, let me just draw an example, right? So if I draw, for example, a plane mirror, okay? In plane mirror also you may see these lines, okay? And you may have a confusion in your mind as to which one is the mirrored surface. The surface which is the reflecting surface is also called as the mirrored surface. Again, this surface where you don't see any lines, this surface is the reflecting surface. Make sense? I hope it helps you. Now let's talk about a convex mirror, okay? So let me draw a convex mirror, okay? You will still see the lines being drawn here, okay? Again, just note these are the lines which are in the plane mirror and the concave mirror. So this was the concave mirror, okay? This is the concave mirror. This is a convex mirror. Convex mirror. Again, this side where you don't have any dashes is the reflecting surface. We are just doing basics right now. Even if you know these, just listen through the video carefully because you will get to know something very insightful from these videos. All right, so I hope this is clear to you. Which one is a reflecting surface? The reflecting surface is also known as mirrored surface, okay? Mirrored surface. Mirrored surface is also one and the same thing, okay? Okay, so this was the plane mirror. I hope this is very clear in your mind. There are 3 types of mirrors which we are studying. You can recognize the construction. So what we studied was a broad construction of the mirrors. So this was more of a high level view of construction of mirror, focusing on which side is the true reflecting side. So construction of mirror, right? This is very important for us to understand. Construction of mirror. All 3, okay? Now let's go to another important point, okay? Another important point I want to tell you is, for example, let's understand. I will show you the figure and then you can relate to this, okay? I'm drawing one mirror, which is this, and then I'm drawing a small mirror, okay? And let me draw a concave mirror. Okay, so in a concave mirror, the inner surface, which is this, is the reflecting surface. The ray of light will strike this. The back surface I'm drawing now, okay? The ray of light does not come here. This is the back surface of the mirror. This is the back surface of the mirror. So, and this is again a concave mirror, but it's a small one. It's a small mirror, okay? All right. Now, what is that? This is a very large concave mirror, okay? And this is a very small, not very small, it's small concave mirror, right? I hope this is making sense. A large concave mirror. And I told you, I don't solve problems directly. I can solve that problem in one sentence, but I will not. I want to give you something which nobody else is giving you. That's the purpose, right? If whatever is already available, you can go and check. But what I'm giving you is not available anywhere. Now, the difference between the 2 mirrors is, and the condition is, if you have a situation where a lot of rays are coming and striking the inner surface, for example, this is the parallel axis, right? Passing through the center of the mirror. You have a lot of rays coming, okay? So a lot of rays are coming, 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 and a lot of rays are coming. In a case where you have a large concave mirror, what you will find is, and I will tell you the exact nature of problem, that the rays of light definitely converge. So remember, a concave mirror is a converging mirror, right? But the mystery is, why did I draw a large mirror and why did I draw a small concave mirror? Even this is a converging mirror, no problem, right? It will converge the parallel rays which are coming to the focus. Now, what you will find here is, the moment you have a situation like this, a large concave mirror, if the mirror, the size of the mirror is very large as compared to the curvature of the mirror, okay? The curvature. You remember the word curvature? Curvature is the radius of curvature, right? The radius of curvature. And this is a large mirror. I told you it's a size, right? So if you find that the mirror size, if the mirror size is very large as compared to radius of curvature, the rays of light which are coming will not converge at a single point, but at multiple points close to each other. So you will not have a single focus. The rays of light will come, for example, the rays of light come here and they converge, for example, in this case here, okay? In this case, they converge here. So the parallel ray came, it struck here. What is the law it will follow here? The law of reflection. Draw a normal and the ray reflects back. What you're adopting now is called as law of reflection, right? So the ray of light comes here, it strikes back, and it is the law of reflection getting. So you have a focus here. Similarly, for example, this particular point you strike here and you pass through this point. And similarly, you come here and you strike here. If you follow law of reflection, this is just another focus. And similarly, you could probably have another situation and one more situation, right? So you can, I'm sorry, I didn't draw a straight line, but this is a straight line actually. It became slightly curvilinear. So you can see if you have a very large mirror size, the size of the mirror is larger than the radius of curvature. You will not get a single focus, but multiple focus. So this is f1, this is f2, this is f3, this is f4, this is f5. But if you see a small mirror, right, a small mirror whose mirror size, okay, the mirror size is very small, not very small, but it's smaller than the radii of curvature, right? If this is the situation and you have parallel rays coming, right, parallel rays coming, I will draw the parallel rays down below. And then of course, the law of reflection, the rays come, the rays come, the rays come, and the rays come. So you can see that in this situation, you have a single focal point or a single focus. All the rays which are coming parallel to the principal axis are moving to a single point, converging to a single point. So remember this, if you see a very large mirror, don't get excited because it will not give you any benefit. Rather, it is a headache to have a very large mirror. Always choose a mirror which is of smaller size in a way that its size is very small as compared to radii of curvature. That mirror will be more beneficial because it will at least focus your parallel rays at a single point. You will get a single focus. Another key point that you learned, when the rays strike the surface, what you do is you draw normal at the surface. At every point where you strike, what you get is a reflected ray and the law of reflection. So the law of reflection gets applied. So for example, this ray has come, struck here, it has gone, draw a normal, and then this is the angle of incidence. This is the angle of reflection. This is the normal. So the law of reflection is the law we actually use to draw the lines. Okay, be very careful when you're using some questions in which you have to actually draw the diagram, or in the laboratory or in the practical. Always ensure that the normal is drawn, and the angle, this angle and this angle are equal. This is an incident angle, this is a reflected ray, this is the normal. So this angle is the angle of reflection R, and this is the angle of incidence, right? I hope you know the law of reflection. So law of reflection gets applied to every type of mirror. Let's move to the next important lesson. Okay, now this lesson deals with one important thing, and it's very fundamental. I'm sure a lot of you would know this. So why do we study geometrical optics? This is a mystery a lot of students have. So why do we need to study geometrical optics? Okay, or the ray diagram, so to say, right? The questions of exemplar you're seeing in front of you is essentially what? It's some kind of a rays. You can see so many rays, and then you have to decide what will happen where, and which of the rays, 4 rays, shows the direction of the reflected ray. So hold on to your thoughts. We're not solving this problem, but I just want to tell you, you can see a lot of rays inside a diagram. And then of course, when you see a lot of rays, the question in my mind was, I should help student understand why do we study geometrical optics, or it is also known as ray optics. It is one and the same thing. Okay, there is no difference. Now you may find this very elementary, very simple, but these are the concepts you have to know, because you will find that as you start solving the problem, these are the places where the students get struck. Geometrical optics, the name suggests it is based on geometry. Okay, so all the purpose of studying the lenses, it covers lenses, it covers all types of mirrors. Both types are covered as part of lenses. The first purpose of studying the lens and the mirror, that is, why do we use geometrical optics to study lenses and mirrors? It is very important because geometrical optics helps us to find the location of image as the object moves along the principal axis. So you would have seen, right, that you have multiple cases. You would have seen object is kept at U is equal to focal point. Object is kept between the center of curvature and the focal point. The object is kept beyond the center of curvature C. The object is kept at the C at different positions, and maybe the object is kept at infinity. At multiple places, when you keep the object as compared to, obviously I have expressed this in terms of the focal length, because in a mirror, there are two very important points which we'll come to, right? Is the point which is the center of curvature, and the second is obviously the focal point. But if you see this, first thing, why geometrical optics is used, why geometry is used for lenses and mirrors, because geometry helps us to find the location of image as the object moves along the principal axis. So when I say that geometry helps, I mean the ray, right? How do you draw the ray diagrams? The ray diagrams are drawn using the rules, which we will cover in the end, right? Second thing, the geometry, which is the geometrical optics or the ray optics, helps us understand the size of the image. Now, how large the image is going to be. So you can understand the magnification of the image, magnification, whether the image will be enlarged, whether the image will be small. So geometry helps you do that, right? Geometry and the rays. The geometry further uses the ray and geometry. The rays follow the geometry, rays follow geometry. Okay, so size of the image is our objective. Finally, when you make a telescope, when you make some application of the mirror or the lens, you're doing it because you finally want to create an image. And creating the image in a camera is very important. In a telescope, periscope, so many instruments are there. Very limited instruments are there in the syllabus of class 10th and 12th. But generally, advanced level physics, you can have many applications of mirrors and lenses. We will currently only focus on the ordinary ones, which are telescope and the microscope and the the journal concave mirror and convex mirror and plane mirror. Okay, so third, it helps you find the third important use of studying geometrical optics is you want to find out whether the image that will be created will be a real image, or will it be a virtual image. This also is very important. A ray diagram which follows some geometry will tell you whether the image is virtual or real. A real image, what is a real image? Where the ray of light actually meet. Rays of light actually meet. What is a virtual image? Where the rays of light do not meet, but it appears as if light is coming from, is diverging. So, if you have a mirror like a convex mirror, a convex mirror generally you will find creates virtual images. So this is the dash, 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 dash. Okay, the object is kept here. The reflecting surface is this, the mirrored surface. This is your object. The ray of light goes parallel. It gets reflected. So a convex mirror is basically diverging. So the rays of light get diverged. So what you will find is that if you extend this point behind, okay, and I'm just completing the diagram. If you so this follows the law of reflection. The ray goes back. What you will find is if you draw this back, okay, this point, behaves in a manner as if the light is coming from here, but it is not. The light is coming from here. This is the imagination, or so to say, illusion that gets created, as if actually the light is coming from here. It is getting reflected and going back. But if you're keeping your eye here, what you will find is you will not be able to see this reflection which is happening. You will see as if the object is kept here and object is sending the light to your eyes. So this particular image, which is an apparent type of image, it gives you an impression it is there, but it is not there. It's called a virtual image. Okay, and generally I have drawn this a solid line. Let me just correct myself so that you don't carry any wrong impressions. The way to do this is you have to, I'm just rubbing this off. Whenever you have a virtual image, what you need to do is something bit different. In a virtual image scenario, you would need to draw dot, 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 dot. This shows that the rays of light are as if they're coming from this point, okay, the object image point, but they're not. So it's a virtual point, right? But if you see another situation where you have a concave mirror generally creates a, so let me draw a concave mirror. Okay, so this is my concave mirror, and my inner surface, which is, sorry, I've drawn a convex mirror. I will draw a concave mirror. So again, I'm sorry, I've drawn a convex mirror. I will draw a concave mirror because my concave mirror, this is the black surface. The mirrored surface is here. My rays of light come, they strike. They go back since they are parallel to the focus, parallel to the principal axis, which passes to the center of the lens. This is the center of the lens. They converge at the focus. One more, so the object is at infinity, hence they are parallel. So, and then of course it's a small mirror. So I told you, small mirror means single focal point. You can see that the rays are truly meeting this point. Truly, they're not coming from behind. That is not the case. So you draw a solid line. You draw a solid line to show that. Okay. I hope this made sense. The concept of solid line, and this is a real image. It actually, the rays are coming and meeting and coming back. And generally, you will see that real images are getting formed in the case of convergence, when they converge. When the rays diverge, like in the case of a convex mirror, generally you will see divergence of rays and a virtual image going hand in hand. And similarly, you will find convergence and a real image going hand in hand. So the convergence and real image. So convergence is happening here, right? This is the case of convergence. This is the case of divergence. Ignore this. This was a mistake. It is not a mirror which I wanted to draw. I wanted to draw a concave mirror, which I have done, right? So this was a convex one. Ignore this. So these are the three important reasons why you study geometrical optics. This is your aim. And of course, someone can add a very small minor point, which is that the same thing can be used for the purpose of what? The same thing can be used for the purpose of finding whether the image is inverted. Inverted means the image becomes, if the image is like this, it becomes this, or the image is erect, right? Which means the image is like this, and maybe the final image is this. Erect means both are same. So this is erect, right? This point is A. This point is A. A still remains here, but in an inverted image, the A goes down, and in the image, and this is the B. So this is an inverted image because the A has become, 180 degree it has rotated. But in this case, this is the image, okay? This is an image of an erect. So this is inverted image, right? Because the A has gone down, and this was your principal axis, so to say. I have not drawn the exact ray diagrams. So 4 reasons why you study geometrical optics. I hope this is making sense. Size, location, real, inverted. Now let's come to the question, and now we will try to link. I will tell you one more lesson on the sign conventions and stuff like that, so that it is clear in your mind how to draw a ray diagram and use the geometrical principles, the geometry, laws of reflection, essentially. All right. So if you look into this question, what this question says is you have 4 rays. Okay. So but fundamentally, the first incident ray which they are referring to is PQ, right? So PQ is the incident ray. So I will just label this. This is my incident ray, right? This is my incident ray, and you know that if you have anything which is happening here, you need to follow a law which is law of reflection. But this is passing through focal point, and we have to identify after it strikes the point Q whether it goes here, or does it go like this. This is very important to understand. We will now study the 3 rules which you must know to solve similar problems, along with what I just told you. So construction of mirror should be clear to you. The concept of a very large mirror versus the radii of curvature should be known to you. You should also understand why do we study geometrical optics. You should also understand that the concept that why do we study geometrical optics, right? So I told you all the reasons we do, and the last lesson will now deal with some rules which you must know, which will go beyond just the question, okay? And you will automatically be able to answer the question being asked. So let's say you have a situation where you have again a concave mirror. Concave mirrors are easy to work with because the ray diagrams are simple. So if you have a concave mirror, remember the rules which you need to follow. The rules that you need to follow. This is your, of course, the principal axis. This is a center. The rule number 1 is if you have a ray which is parallel to the principal axis, it will always go to the focal point. So if you have a rays parallel to principal axis, this is the principal axis, this is the center of mirror. Rays parallel to principal axis will strike the mirror, and reflect back. Look at the reflection. They struck the mirror, they're coming like this. Let me just ensure that we are clear that we are drawing a concave mirror. The inner surface is the reflecting surface. Why I told you the basics? Because I've seen a lot of students who are so-called genius. During the examination, they forget which mirror is it. They're not able to memorize that the mirror is concave or convex. They're genius otherwise. So it is important not to be a genius, but to know the basics. Rays parallel to principal axis will strike the mirror and reflect back to pass through the focal point. So that's your focus or the focal point. Okay. You can call it the focus of the mirror or the focal point. Okay. Number 1, the rays. So this is the number 1 rule you need to know. Okay. So second rule is if this is your focal point, then double of that. So this is your focal length. The double of that is a what is a double? It is a radius of curvature. So this is a point 2f, also called as C, and you're measuring it from here, right? So you can see the measurement. What you notice here is if you have a ray, okay, again, if you have a ray which is passing through the C, okay, let me draw a ray which passes through C. If a ray passes through C, it strikes the mirror. I'm again using a concave mirror, and I'm deliberately using it so that you never forget this is the internal surface, the mirrored surface from where the reflection takes place. If it passes through C, it comes back. So if you find any ray which passes through C, it will come back, right? So this is second thing I'm studying. This was the first one we studied. The second one is if a ray passes through center of curvature and strikes the, I'm using the word reflecting, okay, reflecting surface of the mirror, then it gets reflected back along the incident ray itself. So this was your incident ray. Okay, I'm drawing the incident ray, and now it is coming back. It is coming back from the same point. I will just reverse it. This is the way you need to understand this. Third important point, associate with the first point. If you have a mirror, okay, this is your mirror, again a concave mirror. Now this is the internal surface. If you have a situation where you have this F, this is your radius of curvature 2F. If the ray of light, now if you have a torch, keep the torch here, make the light pass through the focal point. When it strikes the mirror, the reflecting side of the mirror, the one which I'm drawing right now, dash, 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 is the non-reflecting side. This is reflecting side. This is the reflecting side. When the ray of light passes through the focal point or the focus and it strikes the mirror, it goes back parallel to the principal axis. So this is your principal axis passing through the center of the mirror. This is the center of the mirror. This is your principal axis. So if you draw any ray, it passes through the focal point or the focus, it will reflect back parallel to the principal axis. This is the third one. Any ray, any incident, let's call it incident ray, coming through focus will strike the mirror and get reflected in a manner that it goes as a reflected ray parallel to the principal axis. Let's go back to the question now. I hope the rules are clear in your mind. If you see the question, if you see this question of exemplar, the ray of light actually is passing through the focal point. If the ray passes through the focal point, the rule number 3 will get applied, that it will then strike the mirror and become parallel to the principal axis. Where is the principal axis? Where focal point and the center of curvature reside. This is the center of the mirror. So this is the reflecting side of the mirror. This is the non-reflecting dash dash dash. So this one is wrong. So one is wrong. If you look into the ray number 3, right? The ray number 3 is also wrong. And then, of course, I don't see the ray number 4 actually in the question. I don't know where it is, but I can see this is missing in the question. I don't see any ray number 4. Oh, sorry, the 4 is here. No, which is impossible, right? They are sending the ray instead of reflection, it is bending. So this is completely wrong. 4 is completely wrong. They're showing like this, right? So this is your mirror. The principal axis is drawn. The ray of light is then passing through the mirror, right? This is, oh, sorry, this should have been a straight line, but assume this is a straight line. Passes, and then they're saying it will go like this. This is not impossible. So 4 is completely wrong because it is not possible to go on the other side of non-reflecting side. This is a wrong one. So 2 is the only correct choice because 2 is getting reflected and is parallel to the principal axis. So this is your principal axis. This is your principal, and this ray 2 is parallel. So 2 is correct because it is parallel to the principal axis. Many a times you get such questions in entrance examination, school examination, board examination, state board examination, AP physics, very elementary type of questions. But you can see they have given this an exemplar. Exemplar means there's a value, there's a reason why they have deliberately included this, because they know a lot of students do not know these basics. They memorize the formulas and directly start solving, but sometimes the questions may not be associated with formulas, but associated with principles of geometrical optics or ray optics. You can see a lot of rays are being drawn, a lot of geometry is being used, parallel, law of reflection, angle of incidence is equal to, all that is geometry. And of course, the ray represents the light. So I hope this video was informative for you. Simple numerical. I gave you more than just the pure answer. I could have given you the pure answer, but then the point is you don't learn anything. My aim is to impact 1 million students in the country, and so that they can build good career and have good jobs. So it is important that we spread correct kind of education. We don't have too much entertainment and comedy. Instead, we focus primarily on educating. Entertainment can be done. Entertainment is required, but I think it should be done outside the education framework so that you can have relaxation time. But if you start doing entertainment in a physics class or a maths class, you will not learn anything, and that becomes a distraction. You become addicted more to comedy or entertainment and less to the education. So watch this video again, subscribe to my channel. The best explanations given in this channel, which nobody has bothered actually. So I want to revolutionize, change the way this country has physics being spread in a wrong manner. We will change that, and I need your help. So please spread this video in your family, in your friend circle. If they're preparing for some examination, it will definitely benefit them.